Hello and welcome, friend! If you're completely new to Godot, then this tutorial was made for you. In this tutorial, you will go from knowing nothing about Godot to creating your very first game, Danger Dodge. You'll learn the essential key concepts of Godot, which are nodes, scenes, signals, and scripting, and learn the fundamentals of writing gameplay code using GDScript, Godot's custom programming language. You don't need to have any experience with Godot, game development, or programming, because everything will be covered from scratch. This tutorial will give you a strong foundation, but it is just the beginning. If you're ready for a more comprehensive learning experience, check out my complete Godot course in the description. Each chapter of this tutorial is an individual lecture on its own. You can find the table of contents in the description below. With that being said, let's go ahead and get started with the first lecture. Hello and welcome. In this lecture, we're going to download and set up the Godot engine. Let's go ahead and get started. Alright, first of all, let's navigate ourselves to godotengine.org. Inside of here, we're going to click on Download Latest, and then we're going to click on this Godot engine button. Next up, we're going to pick a place to save this file. I'm going to go with the Downloads folder, and we're going to wait for this file to finish downloading. Once that is done, we can click on it to open up the folder. You can see that this is a zip file, so we're going to right-click on it and click on Extract All, Extract. And inside of this folder, we have the executable that is going to launch the engine. So let's double-click on it. Don't click on the one that says console, click on the other one. And that is going to open up the project manager of Godot, where we can create a new project. As you can see, it is extremely simple to download and set up Godot. It is simply an executable file, which is one of the major advantages of Godot. It is very lightweight. Let me also show you this other one. It is the same thing, but it is also going to open up this console window, which is going to display some information. But in this case, we're not really interested in that, so we're simply going to use the other one. You probably don't want to leave this inside of your downloads folder. So what you can do is you can right-click on this, cut it, and then place it inside of your desktop. You can right-click here and paste it if you wanted to. Or you could create a folder to store the different versions of Godot that you're going to use in the future. For example, for me, I have a folder called Godot. And inside of that folder, I have a folder for each version I used in the past. You can see that Godot 4.5.1 is right here, which is the current latest version. So if you like, you can also create a folder structure like this. Let me also show you how to get access to the older versions or the experimental versions of Godot. For that, you can click on this experimental releases button. That's going to take you to the Godot archive. Inside of the archive, you can scroll down and you can find the older versions of Godot. And then you can download them by clicking on the download button. You want to download the stable version, which is the final released version. Underneath the stable version, you're also going to find the experimental releases. And you can also go to the top and you can download a future release. For example, if you want to try Godot 4.6 before it comes out, you can download one of these experimental versions. After you download it, the process is the same. You're simply going to unzip the file and then you're going to double click on the exe file. So that is how to download and set up the Godot engine. We're going to leave it here for this lecture and continue learning in the next one. Hello and welcome. In this lecture, we're going to learn how to create a new project and import our assets. Let's go ahead and get started. So when we launch the engine, the project manager is going to come up. In here, in the middle, you can see the list of the projects you created in the past. For you, this might be empty if this is your first time using Godot. We can also create a new project here by clicking on the Create button. Next up, we're going to give this a name. I'm going to call my game Danger Dodge, but you can call it anything that you want. Next up, we're going to pick a folder location for this. So click on Browse and then pick a folder location that you like. Here is my folder. You don't need to create an empty folder for this. If you have this Create Folder option turned on, that is going to create a folder inside of the location that you specified. If you don't select this, then you're going to have to create the folder yourself. And then you can leave everything as it is and click on Create. That is going to create a brand new project and open it up in the Godot editor. We're going to learn everything about this interface, but in this lecture, we're simply going to import our assets. If you take a look at the bottom left, there's a section called File System. This is going to show us the files inside of our project. It is very much similar to the file explorer that you have inside of your system. We have folders and then we have files. At the moment, you can see that there's a folder called res. This folder refers to the project folder. You can right-click on this and click on Open in File Manager, and that's going to open up the folder that the project was created in. The most important file here is the project.godot file. This means that this folder includes a Godot project. You can open it up with a Notepad application, and you can see some information about the project in here, like the project name, for example. If you create a folder inside of here, it's going to appear in the file system. So for example, here I can right-click, create a new folder. Let's call this assets. That is going to happen inside of our file system here as well. So the res, like I said, refers to that folder location. And vice versa, if I create a folder here by right-clicking, new folder, let's call this scenes, it's going to come up inside of our operating system file browser as well, right here. Okay, next up, let's import our assets. In the resources section of this lecture down below, you can download this file called danger-dodge-textures.zip. Once you do that, you're going to extract it. Right-click, extract all, extract. Here are the textures that we're going to use for the game. I want you to select all of these, left-click on them, and then drag them onto the assets folder. That is going to import them into Godot and specifically into the assets folder. If you mess it up and import it somewhere else, you can always drag these files around and move them just like that, so don't worry. And once you import them, you can double click on them to take a look at them here on the right side. You can also see that there's a file called icon.svj. If you double click on that, it is the Godot icon, and this is included in every project by default. So that is how to create a new project and how to import assets. Like I said, the file system is just like the file browser you have in your system. You can create folders and you can also manage your files. Let's leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to learn the basics of navigating in the engine's interface. Let's go ahead and get started. So first of all, I should say that I am going to go a little bit faster than I normally would explaining these concepts, and that is because we only have 90 minutes or so in this introduction course. In my complete Godot course, I go into deep detail explaining all of these concepts, but like I said, we are going to go a little bit fast in this one. Let's start by taking a look at the middle of the screen where we have the viewport. The viewport is going to show us what's inside of our game world. By default, when we create a project, we start in the 3D workspace. That is why you're seeing a 3D game world. We can click on this button right here to go into the 2D workspace, where you're going to see the 2D game world. Inside of the viewport, we can hold down the scroll wheel button and then move the mouse in order to pan and look at a different location. And we can also use the scroll wheel in order to zoom in and out and see more or less of the game world. On the left, we have the Scene tab, which is going to display the contents of the scene that we're editing. In Godot, everything is made out of scenes. A scene can be a level, it can be the player, the enemy, or a weapon. Anything that you create is going to be a scene. And scenes in Godot are created with nodes. You can think of a node as the fundamental building block, or like a game object. Let's click on this 2D scene option here to create a 2D scene. That is going to add a node 2D into our scene. This is the most simple 2D node that you can create. You can also see it here inside of the viewport as well. We're going to right click on this and click on rename. And we're going to change the name to be game, because this is going to be the main game scene where everything takes place. Next up, we will go into the scene menu up here and save this scene. You can also use the shortcut Ctrl S. We're going to save this into the scenes folder. The name of the file is going to be game, because by default, the name of the scene file is going to be the name of the first node that you create. This is also called the root node. Let's save it. When we do that, the file is going to appear inside of our scenes folder right here, as you can see. And the name of the file is also going to be displayed in the tab right here. Now we can close the scene by clicking on this cross here, and then we can open it back up by double clicking on this file. When you have a node selected here in the scene tab, the properties of that node is going to be displayed on the right here in the inspector section. We can go into the transform and we can see the position, rotation, and scale of this node. you can see that the position by default is 0 on the X and 0 on the Y. And you can see that these are pixels. Because in Godot, in the 2D workspace, 1 unit of space is 1 pixel. So for example, if I set the X to be 100, then the node is going to be moved 100 pixels to the right on the X-axis. Speaking of the X-axis, let's talk about the coordinate system here. If you zoom out a little bit with the scroll wheel, you will see that we have 2 lines going through the screen. This red one is called the X-axis, and it's going to be the horizontal position. And this green one is the Y-axis, and it's going to be the vertical position. The location that these two intersect is right here, and it's called the origin. This is the 0, 0 position. 0 on the X and 0 on the Y. So this is the origin, and it's 0, 0. From the origin, if you go to the right on the X, it's going to be the positive X direction. If you go to the left on the X, it's going to be the negative X. If you go up on the Y, it's going to be negative Y. And if you go down on the Y, it's going to be positive Y. That is how the coordinate system works in Godot, and we can test it by moving this game node. You can left click on it and drag it to change its position. You can see that at the moment it is on the right side on the X, and because of that the X position is positive. We can place it to the left side and it's going to be negative. On the Y, if I place it below the origin, it's going to be positive. And if I place it above the origin, it's going to be negative. And once you make a change to a property, you can always click on this reset button next to it to reset it to its default value. And in the case of the position, that is 0, 0. So like I said, the first node you create inside of a scene is called the root node. It's like the center of that scene, and we usually don't change the transform of the root node. Instead, we create more nodes inside of that scene and play with them instead. So in order to create one more node, we're going to click on this plus button. That is going to bring up a list of all the nodes that we can create. We're going to do a search for sprite 2D. This is a node that is going to display a 2D texture. Let's create it. You can see it right here in the scene tab. If you take a look at the inspector while you have it selected, you will see that it has a texture property that is currently empty. We're going to drag one of our textures from the file system, and we're going to release it inside of that empty slot. And that's going to make it so that the sprite 2D node displays that texture. Then you can left click on it and drag it to move it, just like that. So that is the purpose of the sprite node. Every different type in Godot has a different purpose. Node 2D is the most simple node we can create in 2D. It is usually used as a container node. It doesn't really have much of a functionality on its own. Sprite 2D is used to display a 2D texture, and we're going to learn more nodes in the future with different capabilities. You can see that the sprite also has a transform. So it has a position, rotation, and scale. For the rotation, we can use this slider in order to rotate it, or we can also enter a value manually. We can also change the scale that way. We can left click and drag in order to increase it, or we can enter a value manually to make it twice as large, for example. At the moment, when we change X or Y, the other one also changes because we have this lock enabled. You can click on that, and then you can scale it freely. And like I said, you can always take these back by resetting them, or you can also use the Ctrl-Z shortcut in order to take something back. We also have dedicated tools to do these operations. For example, there's a tool here called the Move tool or the Move mode, and if you click on that, you can click on anywhere inside of the viewport and you can move the node that you have selected. Then there's a mode called Rotation mode. In this mode, you can left click and drag anywhere in order to rotate the node you have selected. You can also hold down the Control key to rotate in 15-degree increments. And then there's a mode called Scale mode, and in this mode you get these squares and you can drag them in order to scale on X and Y. If you want to do a uniform scale, you can hold down the Shift key, and that way it's going to scale in both X and Y at the same time. By default, we start inside of this mode, which is called the Select mode, and in this mode we can do everything. We can left click on a node and change its position. We can use these orange circles to scale it, and we can also hold down the Control key and left click anywhere inside of the viewport in order to rotate it. So it's a combination of all of these different modes. Now for your challenge. Go ahead and create a Sprite 2D node inside of the scene that you created and saved, and give it one of the textures we have inside of our assets folder. Then I want you to play with its position, rotation, and scale, just so you get familiar with these operations. Pause the video, give this a go, and come back when you're done. Alright, so I wanted you to create a sprite just like this one, assign it a texture, and then play with its position, its rotation, and also its scale. If you did that good job, it is important for you to get used to these operations because you're going to be doing them a lot when you're working with Godot. Alright, next up, let's learn how to actually run the game. To do that, we're going to click on this button right here. That is going to ask us to pick a main scene. The main scene is going to be the scene that runs at the start of the game. In this case, we're going to select this one as the main scene. As you can see, the game is running and the sprite is at the center. And that is because it is at the center of this rectangle that we have here. This is called the viewport rectangle, and everything that is inside of this rectangle is going to be displayed when we run the game. So if the sprite is at the center, it's also going to be at the center of the game window. If we place it, for example, at the edge, and only half of it is inside of the rectangle, then that is also going to be the case when we run the game. We can only see the left half that is inside of that rectangle. By default, the size of the window is going to be 1152 by 648. However, we can change this by going into the project settings, into the window section, and then we can give it a different width or height. For example, we could make it 1280 by 720, which is going to be slightly bigger, and it's going to be easier to create the game this way. Alright, so those are the very basics of using the engine, creating nodes, and picking a main scene. We're going to leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to create the player scene and learn how to instance it. Let's go ahead and get started. So in the previous lecture, we created the game scene and we set it as the main scene of the project so that when we run the game, that is the scene that gets loaded. Everything about the game is going to be inside of this scene in the end. The player, the enemies, the background, everything. And like I told you, everything in Godot is created with scenes and nodes. In this lecture, we're going to create the player, and that is also going to be a scene on its own. In order to create a new scene, we're going to click on this plus icon here. We could also go into the scene menu, new scene, or we could just use the shortcut, which is Ctrl-N. That is going to create a new empty scene here. First of all, we need to choose a root node. We're not going to use the 2D scene shortcut here because that's going to create a node 2D, but the player isn't going to be a node 2D. So let's go ahead and click on the plus icon instead, and we're going to do a search for character body 2D. This node right here. This is a physics node, which means it is going to use the physics system of Godot in order to move and in order to interact with other objects. And this one specifically is used to create characters controlled by the player. Let's pick this one. That is going to be the root node, as you can see, and we're going to click on it to rename it to player. Then we're going to save it. I'll hit the Ctrl-S shortcut, and we'll save this into the scenes folder, just like the game. You can see that this character body 2D node has a motion mode property. At the moment it is set to be grounded, but if you click on it, there's also a floating option. Grounded is used for characters with gravity, like platformer characters, like Mario. Floating is for top-down characters, which is what we're going to create. So let's go ahead and change this to be floating. In the scene tab, if you paid attention, you'll see that there is a warning. If you click on it, it's going to say that this character body 2D node needs to have a collision shape. That is right, every physics body node in Godot needs to have a shape so that it can collide with other physics bodies. We're going to create a new node here and we're going to do a search for collision shape 2D. This one right here. This node is going to create the shape of this object. While you have it selected, if you take a look at the inspector, it has a shape property and currently it is empty. We can click on this empty section and we can pick a collision shape type. We're going to use the blue circle texture for the player, and because of that, we're going to go with a circle shape for the collision shape. When you create that, it is going to appear inside of the viewport here. It is this blue circle right here. You can drag this orange circle in order to change its size. But at the moment, we don't have the player sprite in the scene, so we don't know how big to make this. So for your challenge, I'm going to ask you to create a sprite 2D node. One important thing you should pay attention to is to not have the collision shape selected when you click on the plus icon here. You should have the root node selected. Otherwise, the sprite is going to be attached to the collision shape, which is something we don't want. So select the root node when you click on the plus icon. Go ahead and create a sprite 2D node in the player scene. Then I want you to assign the blue circle texture to it. And then finally set the size of the collision shape circle based on the size of the texture. Pause the video, give it a go, and come back when you're done. Alright, let's go ahead and create a new sprite while we have the root node selected. We'll do a search, sprite 2D, created, and then we're going to drag the blue circle image into the texture slot. You can see that the collision shape is very big at the moment, so we'll click on it, and then we'll drag this down to make it smaller. Zoom in a little. Smaller. That should be fine, but as you can see at the moment, the collision shape is behind the player, so when we make it small enough, we can't really see it anymore, which is going to be a problem. In order to make it so that the collision shape is displayed in front of the sprite, we can play with the draw order. At the moment, the collision shape is above the sprite 2D in the scene tab. I'm going to left click on it and drag it below the sprite 2D. That's going to make it so that the collision shape is displayed over the sprite. That is called the draw order of the scene tab. If a node is below another node, it's going to be displayed above that node, over that node. And since the collision shape is semi-transparent, we're going to be able to see it and see the sprite at the same time, which is going to be helpful when we resize it, as you can see. We can even make it a little bit smaller than the sprite in order to make the game a little bit easier. Because if it is perfect, it's going to be very easy to touch the enemies. Something like that should do fine. Alright, that is going to be the player scene. We're going to save it with the Ctrl S shortcut, and then we're going to use this inside of the game scene. At the moment we have the sprite node in here. We're going to click on it and hit the delete key to delete it. And then we're going to click on this instance scene button, and then we're going to pick the player scene. That is going to create a new instance of the player into the game scene. This is the advantage of using the scene system. We can create a scene and then we can use it inside of another scene. And we're also not limited to a single one. If I wanted to, I could click on the root node again, instance another one of these into here. I could also hit the Ctrl D shortcut while I have this selected in order to duplicate it and create another instance. Now I have 3 player instances in the game scene, and I did this by only creating a single player scene. And the real power of this system comes into play when we start to make changes to the player scene. Because all of these instances, they're all connected to the player scene. So if we make a change to the player scene, for example, I could go into the scene, go to the sprite, and set the scale to be 2, and save this scene. Now when I go back to the game, all of those instances are going to get updated, because like I said, these are all connected to the player scene. If I go back and set the scale to be 1 again, save it, come back, they're all fixed. But for example, if I take one of these instances and I set its scale to be 2 individually, that change isn't going to apply to the other instances. Only the changes I make inside of the scene is going to be received by the instances. So in the case of the player, we obviously only want a single one, but if you think of it, if you had an enemy scene, you could put as many enemies as you want into the scene, and you could update them by just changing the scene. All the instances would be updated, which is very nice. Alright, I'm going to drag and select these 2 players and hit the delete key to delete them, and then I'm going to set the scale of this back to be 1. Now when we play the game, we're going to see the player. It looks exactly like the sprite, but now this is a character body 2D that has physics capabilities and a collision shape. Obviously, the next step is going to be making this move, and in order to do that, we're going to learn how to write a script. But finally, in this lecture, I want to say to you that you should never change the scale of the collision shape inside of the transform. You should only change the size of the collision shape using these orange circles, or you could also click on the shape here in the property and then set the radius from here. Never use the scale for the collision shape, otherwise you're going to break it. We're going to leave it here for this lecture and continue learning in the next one. Hello and welcome. In this lecture, we're going to do an introduction to scripting in Godot. Let's go ahead and get started. Okay, so now that we created the player scene with all of its nodes, let's go ahead and make it move. We want to run the game and control the player using the WASD keys. But this functionality by default doesn't exist. We need to create it ourselves. Whenever you want to create a custom functionality, you're going to do it by creating a script and writing some code. So first of all, inside of our file system, let's create a new folder for the scripts. And then we're going to create a new script for the player. We can do that by clicking on one of these nodes inside of the scene tab and then click on this button right here. That is going to create a new script and attach it to the node that you have selected. Usually we're going to attach this script to the root node of the scene. So in this case, let's click on the player and click on this button. Here we can give this a name and also specify the folder location. The name of the script is going to be the name of the node that we're attaching this to. In this case, it is called player, which is fine. By default, this is being placed into the scenes folder. Let's change that by placing it inside of the scripts. You can see that this is going to use a template, which is going to give us some code. By default, this might be set to character body 2D, basic movement. You're going to pick the node default version. The basic movement is for platformer characters, which in this case isn't going to work. So we'll just go with the default template. You can also see that the language is set to GDScript, which is the programming language of Godot that we're going to learn. Let's go ahead and click on create, and that is going to create a new script. You can see that an icon appeared next to the player root node right here, indicating that it has a script attached. You can also see this file inside of our scripts folder, player.gd right here. We also automatically switched into the scripting workspace right here. In the middle, we can see the contents of the script and we can edit it. On the left, we can see the files that we have open. In this case, we only have a single one. And below that, we have a list of all the functions or the methods inside of the script. In this case, we have the ready and the process function, and these came with the template that we picked. So let's go through this file and understand what it does. First of all, at the top, we have the extends keyword, and next to it, we have character body 2D. This means that this script is going to extend the functionality of the character body 2D type or the class. This is because we attached this script to the player, which is a character body 2D. The script that you create has to match the type of the node that you attached it to. And because of this connection, we're going to be able to use the functionality of a character body 2D in order to make the player move. Then we have two functions here, ready and process. A function is basically a block of code that is going to be executed. The ready function is going to be executed or called at the start of the game, and process is going to be executed every frame of the game. Above these functions, we have these lines that start with a hash symbol. These are called comments and they don't have any effect. They're simply notes left by the developer in order to explain what the code does. For example, this one right here is explaining what the ready function does, and this one right here is explaining what the process function does. You can create your own comments by typing a hash symbol, and then you can type anything that you want. And like I said, it doesn't have any effect. It is merely just a note. Then we have the function declarations that start with the func keyword. So this is creating a function. After that, we're going to type the name of the function, in this case, _ready. Then a pair of parentheses with the argument list. In the case of ready, it is empty because it doesn't accept any arguments. And then we have the return type and then a colon. We're not going to get into the details of the arguments and the return type. Just know that this line is creating a function called ready, and this line right here is creating a function called process. After the function declaration, we have the body of the function, which is right here. The body of the function needs to be indented with a tab, as you can see. In this case, both of these functions have the pass keyword inside of them, and that means they don't have any code, so they're essentially empty. These functions are called automatically by Godot, ready at the start of the game and process in each frame. So let's learn how to print some text inside of ready. We're going to get rid of this pass statement and this comment. We're going to type print, that is the name of the function that we want to call. and then we're going to put down a pair of parentheses to make the function call. And inside of those parentheses, we're going to create a string, and you do that by placing down 2 double quotes. In the middle of them, you're going to type your string, let's say hello world. This function call is going to print the text hello world to the output tab, which is at the bottom right here. The output tab is going to show our print functions, and it's also going to show any other message that the Godot engine wants to show us. Now, if we play the game and take a look at the output tab, you will see that hello world is going to be printed. And it's only printed once at the start of the game because, like I said, that is how ready works. And we can do this as many times as we want. We can have a bunch of code inside of the function body. Let's change these messages. Let's say hello again, and hello for the final time. The code is executed top to bottom. So in a function, we go from the first line to the last line. In this case, hello world is going to be printed first, then hello again, and finally hello for the final time. That is how the code flows. And if we play the game, you will see that that is indeed the order. So that's how to print some text inside of the ready function. Now I'm going to give you a challenge. Go ahead and print a message inside of the process function and play the game and take a look at the difference between ready and process. Pause the video, give it a go, and come back when you're done. Alright, inside of the process, we're going to get rid of the pass keyword and we're going to place it with a print. And this time, let's just print process. Then we're going to play the game, and you're going to see that as long as the game is running, we're going to continuously print the process message. You can actually see how many times it is being printed right here, and this corresponds to the frames per second of the game. So for example, if the game is running 60 frames per second, we're going to print process 60 times a second because this function is called every frame of the game. So whenever you want to do something over time, over and over again continuously, you're going to do it inside of the process function. And whenever you want to do something once at the start of the game, you're going to do it inside of the ready function. So that is the difference there. So that is a gentle introduction to scripting in Godot. You can see that we have some numbers next to the lines. These are the line numbers, and these make it easy to read the code. You can also see that some of these words have colors, and this is called syntax highlighting. It makes it easier to read the code. And inside of the scripting editor, Godot tries to make it easy for us to write code as well. So for example, in the function body, if you create a new line, that is going to be automatically indented. If you place down a single parentheses, the other one is also going to get created. Also, if you create a single double quote, the next one is also going to get created. So we have these various different shortcuts to make it easier for you to write some code. You can see that this line doesn't really fit into the screen. In order to fix this, we can go into the editor settings. We're going to do a search for word wrap and click on text editor appearance. And here you can turn on word wrap so that the lines that don't fit are displayed on the next line, which I think makes it easier to read it. You can also turn on another setting there, which I like to turn on usually. So we'll scroll down to text editor behavior, and we're going to enable scroll past end of file. And that is going to let us scroll to the end of the file, even if there's no code. And this is also going to make it easier to read the file. All right, we can save this, hit Control S. One important thing to realize is that the player scene has an instance inside of the game. And when we play the game, we're running the game scene because that's the main scene. So if we didn't have the player in here, if we delete it, the script isn't going to be run because it doesn't exist in the game. So it has to be here. I'm going to hit Control Z to take that back. It has to be in the scene that we're running in order for the script file to be activated. All right, we're going to leave it here for this lecture and continue learning in the next one. Hello and welcome. In this lecture, we're going to learn how to use variables in GDScript. Let's go ahead and get started. Okay, so variables are a very important concept in programming. They're essentially containers that let us store data. Data like the strings we have been printing using the print function. So let's get rid of these print statements. I'm going to delete the one in process, and I'm going to replace it with a pass keyword, which is going to mean that this function is empty. Then I'm going to delete these two from ready, and I'm going to leave this other one. At the top of ready, we're going to create a variable. To do that, we need to use the var keyword, and then we need to give it a name. I'm going to call this my variable. In GDScript, we have an underscore in between each word. That is the naming convention. This is going to create a variable. We can also assign a value to this using the assignment operator, which looks like this. It is the equal sign. This is going to assign whatever we place after it into this variable. For example, we could assign this string. I'm going to cut it from there and place it here. And then we can print the variable instead of the string. And to do that, we need to type the name of the variable into the parentheses of the print function. Now we created a variable called myVariable. We have assigned it a value, which is this string called hello world, and then we're printing it. So now when we run the game, it should look very similar to what we were doing before, but now we're doing it using a variable. Variables in GDScript can have different types of data. These are called the data types of the variable. One of them is a string, but we also have other types. For example, we can create numbers like 10. This is a whole number and it's called an integer. We can also have a fractional portion like 10.5, and this would be a float. There's also a type called a boolean, which can have true or false as its values, and these are used in conditions, and we're going to explore how to use these in the upcoming lectures. Using the number types like the integers and floats, we can do mathematical operations. For example, I can do something like 10 plus 2. When we run the script, this calculation is going to be evaluated. It is going to be 12, and then 12 is going to be assigned into my variable using the assignment operator, and then we're going to print it. So now when we run the game, we should get 12, as you can see. We can also do a subtraction using the minus operator, which is going to be 8, and we can also do a multiplication using asterisk and division using the forward slash. These are some of the mathematical operations we can do. And we're not limited to a single one. We could do a multiplication after this, addition after that, anything that we want. And the regular rules of math is going to apply here. So division and multiplication will be done first, and after that addition and subtraction is going to be done. And in the case where we have a division and multiplication next to each other, the one on the left is always going to be done first. You can override any of these operations by using the parentheses. So for example, if I do a parentheses here, the addition is going to be done before the division or multiplication. And we can do all of these operations using floats as well. So I can turn any of these numbers into a float by using a decimal point, just like that. If we run the game, I don't even know what we're going to get. I guess that is the result of that calculation. After we create a variable, we can assign a value on another line. For example, I could say my variable is now 2. So in the first line, we created the variable and we assigned it an initial value. But on the next line, we assigned 2 to it. So now if you print it, it is simply going to be 2, and that other calculation is going to be gone. As you can see. We can also use these variables in operations. So for example, I'm going to set my variable to be 10, and then I'm going to create another variable that's called a second variable. I'm going to assign an initial value, and I'm going to say my variable times 8. So as you can see, we can use the variable in a number operation like this. In this case, my variable is 10, so the result of this is going to be 80. That is going to be assigned into second variable. And if we print the second variable instead of my variable, we should be printing 80. So these are the number operations and the basic types we have in GDScript, but we also have more sophisticated types like a vector. I'm going to get rid of the second variable and continue printing my variable. In order to create a vector, we're going to use the vector constructor, which is a special function that looks like this. First, the name of the type we want to create, which is vector2, and then a pair of parentheses. A vector is a special data type that is going to store two numbers, x and y. When we create a vector, we need to provide these numbers. In this case, I'm going to provide 10 and 8. And this is going to create a vector that has 10 for the first number for the x and 8 for the second number, y. We can print this like any other variable. We can also access these numbers individually using the dot operator on the variable, and then x for the first number or y for the second number. So if I print my variable.x, it is going to print 10. And if I try to print my variable.y, it is going to print 8. So the vector type is going to group two numbers together, and this is going to be very good for representing positions, representing scale, anything that needs to be represented with two numbers. In fact, if you actually click on one of these nodes here and you take a look at its transform, you will see that the position, for example, is a vector too. It is two numbers, one is x, the other is y. You can also see that the scale is vector too. So this is a data type that is used widely in Godot. In the end, we're going to use it to determine the direction of the player. At the moment, we're creating these variables inside of the ready function, and that means we can only access them in this function. For example, if I try to print my variable in process, it is not going to work because it is declared inside of ready. If I want to access it in multiple functions, I need to create it outside of these functions like that. If you declare it there, you can access it from any functions inside of the script. So now I should be able to play the game, and my variable is going to be printed in process, as you can see. This is called the scope of a variable. If you create it inside of the scope of a function, you can only use it there, but if you create it in the scope of the script, you can use it in any of these functions. Now that we understand these on a basic level, let's give you a challenge. Go ahead and create a variable called speed and give it an initial value of 300. Then I want you to print this in the process function. You have two options. You can either create the speed variable in the process function, or you can create it in the scope of the script and then use it in the process function. Pause the video, give it a go, and come back when you're done. Alright, I'm going to do this in the scope of the script. So underneath my variable, we'll say speed using the var keyword, and then we're going to assign this an initial value of 300. If you type in 300 like this, it is going to be an integer. In this case, I want this to be a float, so I'm going to type in .0 as well, and that is going to make it a float. And after this, we can print it in process, so instead of printing my variable, I'm going to print speed. And now we should be printing 300 in process in every frame. In the end, we're going to use this variable to control how fast the player is moving. So these are the basics of using variables in GDScript. We're going to leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to learn how to make the player move using velocity. Let's go ahead and get started. Okay, so first of all, let's go into the player script. In here, we're going to learn how to make the player move. Since we created the player as a character body 2D, we have access to the physics system. There's a function we can call. We're going to call this in the process. I'm going to get rid of the print statement. This function is called move and slide. The move and slide function is going to move us based on the velocity. It's not going to work on its own, so if we try to run the game now, we're not going to move because the velocity is 0. We can set a velocity using the built-in velocity variable, which looks like this. You can hold down the control key and click on this variable. That is going to take you to the documentation page for it. And here you can see that it is a vector too. So it has an x and y property. These are going to control our speed and direction. So for example, if the velocity is 100 on the x and 0 on the y, we're going to go to the right at the speed of 100. And that is because x is going to control the horizontal direction. And if it is positive, that means we're going to go in the positive x, which is right. If this was negative 100, we would go to the left direction at the speed of 100. And if the x was 0, but the y was 100, we would go down, because in Godot, in the y-axis, going down is positive. And if this was negative 100 on the y, we would go up at the speed of 100. And we can combine these two together to go diagonally as well. And we need to do this inside of the process function because we want to do this over and over again as long as the game is running. If we do it inside of ready, we can only do it once at the start of the game, which isn't really going to be useful. So let's go ahead and set some values to the velocity. We have two options. We can either set the x and y properties individually like this, or we can set it directly to the velocity using a vector 2, using the constructor function, just like that. In this case, we're going to provide x and y in one go. So let's start by moving it to the right. So I'll say 100 for the x and 0 for the y. Now when we play the game, you're going to see that we're moving to the right. I can make this negative for the x. That is going to make us go left. And we can also change the y as well. So let's set x to be 0, 100 for the y. This should make us go down. And we can go up as well by setting this to be negative. And you can use a different number than 100 to go at different speeds. For example, I could set this to be 50 and we would go slower, as you can see. So the velocity variable is going to control our direction and speed, and move and slide is actually going to use that velocity to make us move. If you are a little bit advanced and you're thinking of frame rate independent movement, move and slide is going to be frame rate independent by default. There's an argument here that we can use to make something frame rate independent. In this case, we don't need to use it because, like I said, it is used inside of this function by Godot itself. If you don't know what that means, that is okay. We're not going to cover delta or frame rate independent movement in this short course, but in the complete course, I go into detail explaining it. Alright, now that we learned how to make the player move, I'm going to give you a challenge. Go ahead and make the player move to the top left direction using the velocity variable. Pause the video, give it a go, and come back when you're done. Alright, we want to go to the top left direction. That is going to be negative on the x, and it's going to be negative on the y as well. And that's going to result us in going to the top left. So we can do something like negative 100 and negative 100. If we wanted to go exactly to the top left, we could use something lower than 100 for the y, something like 50 perhaps. And that is going to make us go exactly to the top left, as you can see. Great, so that's the challenge. Next up, we're going to start using a different process function. And that function is going to be the physics process, which looks like this. It's going to be the same functionality as process, but this is the version that you need to use if you want to do something that has to do with the physics engine. In this case, we're making the player move, and the player is a physics body, so we should do it inside of physics process. If you play the game, it's going to be exactly the same, but like I said, this is the proper way to do it. Alright, next up, we're going to create a variable to control the direction of the player. At the moment, we're using this hard-coded vector 2, which is controlling both the direction and the speed at the same time. To control the speed, we're actually going to use this variable we created, and then we're going to have a vector 2 that determines the direction. We'll create this vector 2 here in physics process. We're going to call this direction, and we'll set this to be a vector 2. By default, we're going to make this 0, 0. 0 is going to mean no direction. 1 is going to mean going to the positive side. And negative 1 is going to mean going to the negative side. So for example, if the direction is 1 by 0, this is going to mean go to the right. If it is negative 1 by positive 1, it means go to the left on the x and go down on the y. So this would mean go to the bottom left. And then we're going to take this vector and we're going to multiply it with the speed. So that in the case of 1, 0, it is going to be 300 and 0. So we're going to go right at the speed of 300. This way we can control the direction and the speed independently from each other. So instead of setting velocity to this hard-coded value, we're going to set it to direction times speed. If we run the game now, the player isn't going to move because the direction is 0 and 0, but I can set it to be 1 by 0, for example, and that's going to make us go right. Negative 1 is going to make us go left, and all the other combinations are going to be the same. So this was how to make the player move using the move and slide function along with the velocity variable. The next step is going to be moving the player based on input, but to do that we need to learn input actions first, and we're going to do that in one of the upcoming lectures. Let's leave it here for this one and continue in the next lecture. Hello and welcome. In this lecture, we're going to learn how to write an if statement and get player input so that we can finish up the player movement code. Let's go ahead and get started. Okay, so at the moment we can make the player move by giving it a velocity inside of the physics process function. In there we created a variable called direction that is going to control the direction of the movement. the x value is going to control the horizontal direction and the y value is going to control the vertical direction. Then we're going to multiply this with the speed variable that is going to control how fast we go, and after that we're going to assign this into the velocity variable and then call move and slide to make the player move. We learned that we get these functions and variables like velocity and move and slide because we're extending the character body 2D class, which is what the player is. It has access to the physics system. This is all great, but we want to do this based on player input. For example, when we press the D key, we want to set the direction's x value to be 1 so that we go to the right. When we press A, we want to set this to be -1 so that we go left. When we press W, we want to set the y value to be -1 so that we go up. And when we press S, we want to set the y to be +1 so that we go down. In order to implement this, we need to learn how to get input from the player. And before we do that, we need to learn how to run code based on a condition, because we only want to move if a key is pressed. So first we need to learn how to write an if statement so that we can run code based on a condition. And after that we need to learn how to get input, and then we're going to combine these two in order to create the player movement code. So that's the plan. First of all, we're going to learn how to write an if statement in the ready function up here. I'm going to get rid of this print statement. Then we're going to say if. And after the if, we need to create a condition, which is going to be a Boolean value. It's going to be true or false. If it is true, then the if statement is going to be executed. After the condition, we need to put a colon. And then after the if statement, we need to indent by 1 tab. In this case, as an example, we can print something here. Let's say if is true. If the condition is true, everything that is indented after the if statement is going to be executed. So in this case, when we run, if is true is going to be printed. But if we put false in the condition, in that case, everything after the if statement that is indented is going to be ignored. So in this case, nothing is going to be printed. So this is how a very basic if statement works. What we want to do is, instead of typing true or false, we want to check if a key is pressed. So we want to say if W is pressed, set the direction.y to be -1, for example. But in order to do that, we need to learn how to get input. So that is going to be the next thing. We can get rid of this if statement. In fact, we can get rid of the entire ready function. We're not going to use it. In order to get input, we need to use the input action system. We can do that by going into the project settings menu, into input map. In here, we need to create new input actions. We can do that by clicking on this section here and give it a name. First of all, we're going to do move right. After you give it a name, you can just hit the enter key to create that input action. And then we're going to assign a key or event to this input action by clicking on this plus icon. Here you can find the button that you're looking for from these lists, or you can just hit that button on the keyboard, because as you can see, it says that it is listening for input. So I'm simply going to hit the D key, and that is going to select the D key on the keyboard. Then we can click on OK. And now the D key is going to be associated with the move right input action. We're not limited to a single button. We can bind as many keys or events that we want to. For example, I can do this again, and this time hit the right arrow key. And I can also bind this one. So now both the D key and the right arrow key are going to trigger the move right input action. Now we need to do this 3 more times for move left, move up, and move down, and I'm going to give that to you as a challenge. Go ahead and create the rest of the input actions. These are the names, and after you create them, you're going to bind the correct keys to each action. Pause the video, give it a go, and come back when you're done. Alright, first of all, let's create these actions. Move left, enter, move up, and move down. For move left, we're going to bind the the A key, and then I'm also going to bind the left arrow. For move up, we're going to bind W and also the up arrow. And for move down, we're going to bind the S key and the down arrow, just like that. So these are going to be our input actions. Now let's learn how to use them. We're going to do this right after we create the direction and before we set the velocity. There's a function that is inside of the input class. we can access it by typing input with a capital I, and then we can use the dot operator to access the function, and the function is called isActionPressed. We're going to pass the name of the input action that we want to check for as a string. So we're going to create a string, and first of all, let's do a check for move right. This function right here is going to be true if the move right input action is pressed, and it's going to be false if the move right input action is not pressed. We can actually check this by printing this. So just create a print statement over this function call. And since we're doing this in physics process, this is going to happen over and over again. Now when we run the game, we're going to print false, but if I hit the D key, it's going to turn true. If I let go, it's going to be false again. So as you can see, this function is true when we press the input action that we specify, and it's false when we're not pressing it. We're going to combine this with an if statement. So let's get rid of this print statement. And instead of the print, let's make this an if. At the end, we need to put a colon. And then on the next line, we're going to indent one tab and we're going to do something. In this case, what do we want to do when the D key is pressed? We want to set the direction's X property to be 1 so that we go right. So first of all, let's set it to be 0 at the start. And then in here, we're going to set direction.x to be 1. So that by default, if nothing is pressed, we're not going to move. And then if the right button is pressed, we're going to go right. As you can see at the start, we're not moving, but if I hit the D key or the right arrow key, I will start moving to the right. Perfect. Now all we have to do is repeat this 3 more times for the other directions. First of all, let's copy and paste this. And let's do left. So we'll change the input action name to be left. And then instead of setting it to be 1, we'll set it to be -1. That will make it so that we can go left with the A key, just like that. And next up, we're going to do up and down. We can copy and paste this one more. Change the name to be move up. This time we need to change the Y property of the direction, not the X. And we're going to set it to be -1 because we want to go up. And in Godot, going up on the Y is negative. As you can see, it's working. Now let's do that one more time so that we can go down. We'll change the name to down. And this time we'll set the Y to be +1. And now with this, we can go in all different directions, as you can see. We are a little bit slow, so I'm going to set the speed back to be 300. Just like that. There's a small problem with this. When we go diagonally, we're actually going to go faster compared to our horizontal and vertical movement. And that has to do with the length of this direction vector. So after we do all of this, I'm going to print the length of this vector, which we can do by calling direction.length. And this is a function. You will see that when we go left or right and up and down, it's going to be 1. But if we go diagonally, it's going to be 1.4. This means that we're moving faster when we go diagonally. In order to fix this, we're going to normalize the direction vector. We can do that by calling direction.normalized, and then we can assign this into the direction. Just like that. Now when we play, and when we go diagonally, it is going to be 1 again. It's saying that it is 0.9999, but for all intents and purposes, that is 1. This is going to make sure that we go in the same speed in all different directions. Awesome, hopefully everything is clear. We're using an if statement plus the input function in order to run some code based on a condition. And we're controlling the values of the direction variable to control the direction that we go in based on that input. And with that, we're going to finalize the player input code. We don't need to print the length anymore. We can also get rid of this comment. And you can see that we are getting a warning here because this line is yellow. If you click on this button, you can actually see the warning. We're getting this warning because we're not using this delta variable. You can put an underscore in front of it to let Godot know that we don't want to use it and it's okay. And with that, we're going to leave it here for this lecture and continue learning in the next one. Hello and welcome. In this lecture, we're going to create walls so that the player can't leave the game area. Let's go ahead and get started. So now that we created the player movement code, we can move inside of the game area freely. But there's a problem. We can also leave the game area, as you can see. Since the game we're going to create is going to be limited to the screen, we don't want the player to be able to do this. In order to prevent it, we're going to create walls around the game area. And to do that, we're going to learn how to use a static body 2D node, which is a new physics node that we're going to learn. So inside of the game scene, we're going to click on the root node, and then we're going to create a new node. We're going to do a search for static body 2D, this one right here. This is a physics node just like the character body 2D, but this one doesn't move. It's a static physics object that can't be moved, but other physics objects can collide with it. We're going to create one of these. We're going to rename it to wall. Just like character body 2D, this one also needs a collision shape. So while we have it selected, we're going to create a collision shape 2D. For the shape, we're going to use a rectangle. So we'll go into the inspector, create a new rectangle shape, and then we're going to resize it to cover the top portion of the screen. I'm going to hold down the Alt key and then drag the right edge of this to make it larger. Something like that. And then we're going to position this to cover the top portion, just like that. Now that we have this in the game, if we try to leave the game area from the top, you're going to see that we can't. When we hit the static body, we're not going to be able to move anymore. And at the moment, the static body is invisible because it doesn't have a sprite, and that is fine because in the end, it's going to be outside of the game area, just at the edge of the viewport rectangle. And because of that, we're not going to be able to see it anyways, so there's no really point creating graphics for it. What we need to do is we need to turn this into a scene because we're going to use it 3 more times. Instead of creating a new scene, we can simply right-click on this and then click on Save Branch as Scene. That is going to save the wall and the collision shape as a new scene. Just like that. Now we can open that scene up by clicking on this icon, and here it is. We don't need to do anything in the scene here. We simply need to use it again inside of here to create the other walls. But first of all, I'm going to position this exactly at the edge of the viewport rectangle, just like that. And then I'm going to give you a challenge to create the bottom wall. So go ahead, like I said, create the bottom wall with another instance of the wall scene. Pause the video, give it a go, and come back when you're done. Alright, we can either click on the Instance New Scene button, or we can simply duplicate this one. So while I have it selected, I will hit Ctrl D. That is going to duplicate it. And then I'm going to go into the Move mode, and then move this to the bottom, exactly at the edge of the viewport rectangle. Just like that. That is going to be the bottom wall. As you can see, it is working. And next up, we're going to create the left and right walls. So we'll go ahead and duplicate this one. Move it up, and we're going to rotate it. So I'll go into the rotation mode, and then I'll rotate holding down the Control key by 90 degrees, just like that. And then we'll place this to the left edge. You're going to see that this collision shape is far too large to be on the left side. But if we try to change the collision shape from the scene, all of the instances are going to receive that change, which isn't going to work. In order to change the children of a single instance, we can right-click on it and then click on Editable Children. That way we can access the children of that instance and then modify them. But even then, if you try to change the collision shape, you will see that every other collision shape is going to be affected. As you can see. That is because all of the instances of the wall are sharing the same shape resource. So what we need to do is, first of all, I'm going to make this larger to fix it. And then we're going to right-click on the shape resource of the wall 3 here. And we're going to click on Make Unique. That is going to make it so that this shape resource is unique and it isn't shared by anything else. That way, when we change the size, the others are not going to be affected, as you can see. So that can certainly be confusing, and that is the reason for that. All the instances are sharing the same resource, and Godot does this in order to make things more efficient. And finally, we're going to duplicate this one and then place it on the right side. Now we should be able to play the game, and we shouldn't be able to leave the scene in any of these directions. Perfect. So that is the wall. I'm going to create a container node to store all of these walls we have. I'll click on the root node, and then I'll create a node 2D. I'm going to rename this to walls, and then I'm going to select all of these instances. I'll click on the first one, hold down the shift key, and click on the last one. That is going to select all of them, and then I'm going to drag these onto this walls node right here. That is going to make them a children of that node. That way I can store all of them under a single container just like that. And then I'm going to take these and put them behind the player in the scene hierarchy. So that is how to use the static body 2D node in order to create walls that prevent the player from escaping the game area. We're going to leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to create the enemy and we're going to learn how to use the animation player node. Let's go ahead and get started. Okay, so first of all, there is a small mistake here. If you take a look at the collision shape of these walls, you will see that they are at a small offset. We're going to fix this by clicking on them and then resetting their transform. We need to do this for the other one as well, so that the collision shape is exactly on top of the static body 2D. If you have the same problem, you can fix it that way. And now let's go ahead and create a new scene for the enemy. The root node is going to be a node 2D. We're going to rename this to be enemy, and then we're going to save this inside of the scenes folder. We're also going to create a script for this. It is going to be called enemy.gd. I'm going to place this into the scripts folder. We don't need to have a template for this, so if you have the template turned on, you can turn it off. And then we're going to create it. We'll use this later. For now, we're going to create the nodes inside of the scene. So first of all, let's think of how the enemy is going to work. Well, the enemy is going to be a physics body, just like the character or the player. It's going to have a collision shape. And we essentially want to detect when the player overlaps with its collision shape, so that we can reset the game. In order to do this, we can use the area 2D physics type. This is a physics body that isn't going to have any collisions, but it is going to be able to detect if another physics body enters its collision shape. So it is perfect for what we want to do here, because we don't want the player to touch the enemy and then bounce, or touch the enemy and then cause physics calculations. We simply want to detect it. So here in the enemy scene, we'll create another node. We'll do a search for area 2D. Since this is a physics body, it's going to require a collision shape. So we'll create a collision shape for it as well. Make sure to have the area 2D selected and not the root node, because the collision shape needs to be a child of the area 2D. Then we're also going to create a sprite for this. Again, selecting the area 2D, we will create the sprite, and I'll place the sprite behind the collision shape so that we can see the collision shape as well. We're going to do it this way because we're going to animate this area 2D. If we weren't going to animate it, I would just create the area 2D as the root node. So for the sprite, let's use one of our enemies. I'll just use the red one for now. And then we'll create a collision shape, and the shape can be a rectangle about that size. The bigger you make this, the more difficult the game is going to be. For now, let's make it this size, and later we can change it if we don't like it. Great, next up we're going to learn how to animate the enemy, because we want the enemy to move back and forth just like that. In order to do this, we can use a node called animation player. We're going to add this node to the root node. It is called animation player, like I said, this one right here. And this node is going to animate the position of the area 2D. When you select the animation player, the animation window is going to pop up on the bottom right here. Here we can click on this menu in order to create a new animation. We're going to call this move. When you create a new animation, you're going to get this timeline with this pointer. You can use the left mouse button to scroll through the animation. By default, you can see that it is 1 second long, but you can change this number to make the animation longer or shorter. We can click on this button right here to make the animation automatically play at the start of the game. And then we can key different properties in the timeline in order to animate them. First of all, we're going to make sure that the pointer is at the start of the animation at 0. And then we're going to click on the area 2D. Once you do that, you will see keys next to all of its properties. We have these because we have the animation window open, and we can key any of these properties into our animation. We will go into the transform section, and we're going to key the position of the area 2D. Make sure that the area 2D is at 0, 0. This is going to be the start of the animation. So click on the key icon here, and then click on create. That is going to create this key right here for the position of the area 2D at the start of the animation. Next up, we're going to position the area 2D at the bottom of the viewport rect, and then we're going to key it for the end of the animation. So first of all, we need to scroll through to the end. Make sure to do this first. And then we're going to change the position of the area 2D, and then we're going to key it again. We're only going to change the Y position. I'm going to give that to you as a challenge. So go ahead and position the area 2D to the bottom of the viewport rect and key its position in the animation, just like I did for the first position. Pause the video, give it a go, and come back when you're done. Alright, while we have the animation window open, we're going to click on the area 2D, and in the position for the Y, I'm going to set this to be 600, which is going to be enough. You can also use something higher if you want the enemy to go lower on the screen. But I want the enemy to always stay in the screen. I don't want it to get out, so I'm going to use something like 600. Make sure to have the pointer in the timeline at the end when you do this. If you do it at the start, it's not going to work. You need to scroll to the end, set the position to 600, and then click on the key, which is going to create the second key in the animation in the timeline right here. Once you do this, you can scroll through the timeline and you will see that the position is being animated. You can click on this button to play the animation from start to end. We can click on this button right here to make the animation loop. Now when we play the animation, it is going to loop as you can see. But there's a problem. When we reach the end, the enemy snaps back to the beginning. In order to fix that, we're going to click on the loop button again, and that's going to make it loop back and forth, as you can see, which is what we want. We can also make this animation look a little bit more natural by clicking on this button right here and set it to be cubic. And that way, as you can see, it has a more natural, more smoother feel to it. Great, so that is the animation. We can stop it and scroll to the beginning and then save the scene. Next up, we will go into the game scene and we're going to instance an enemy. We're going to click on the root node, instance a new scene, click on the enemy, and then we're going to bring it next to the player. Then we're going to play the game to see what it looks like. And as you can see, it is looking good. Currently, it doesn't do anything, but we're going to fix that very soon. For now, I want to create a container node for the enemies, just like we did for the walls. So we'll click on the root node, create a node 2D, and we're going to rename this to be enemies. And then we'll drag the enemy into this node, and then we'll position this behind the player. The next steps here are going to be detecting the player when it touches the enemy, and then resetting the game. We're going to do that very soon in one of the upcoming lectures, but we're going to leave it here for this one. This was how to create the enemy scene and learn how the animation player node works. I will see you in the next lecture. Hello and welcome. In this lecture, we're going to reset the player when the enemy touches it using signals. Let's go ahead and get started. Okay, so now that we created the enemy, the next logical step is going to be implementing what's going to happen when the enemy touches the player. In this case, we want to reset the position of the player to the start of the game, which is going to be here on the left, so that the player has to go through the level again. We can do this by using signals in Godot. Signals are emitted when certain events happen inside of our game. every node in Godot has the ability to emit a signal, and different nodes have different signals. For example, we created an area 2D for the enemy. If you click on it, and if you click on the signals section here on the right, you can see all the signals that this node can emit. We're interested in the ones at the top here underneath the area 2D section. These are the signals specific to the area 2D node type. And in here, there's a signal called body entered. This signal is going to be emitted when a physics body overlaps with the area 2D, for example, the player. When this happens, the signal body entered is going to be emitted. What we can do is we can connect this signal to our script so that we have a function that is called when this signal is emitted, which means we can do something, we can respond when a physics body enters the area 2D of the enemy. That is how the signal system works. It lets us communicate between nodes and scripts so that we can do something, we can run code when certain events happen. In this case, we're going to connect the body entered signal to the script inside of the enemy scene. And to do that, we can select it in the list here, double click on it, or we can click on the connect button down here. In the list of nodes here, we're going to select the enemy node with the script, and then we're going to connect. That is going to create that connection, and a callback function is going to be created inside of the enemy script. This function is called onArea2D body entered. And that is because this function is going to get called when the body entered signal of the area 2D is emitted. Inside of this function, we're going to print a message and we're going to see what happens when we touch the enemy. And I'm going to give that to you as a challenge. So go ahead, like I said, print a message in the callback function and try touching the enemy. Pause the video, give it a go, and come back when you're done. Alright, we're going to get rid of this pass statement, and then we're going to say print body entered. You could have used any message, it is not that important. We're going to save this and run the game. And now when we touch the enemy, we're going to get the body entered message each time it happens, as you can see, which means each time we touch the enemy, the function that is created here is called. Which also means we can reset the player in this function instead of printing a message. To do this, we're going to create a function inside of the player. So go into the player script. At the bottom, we're going to create a function to reset the player. We need to use the func keyword to create a new function. Then we're going to give this a name. I'm going to call it reset player, parentheses, colon, and then on the next line, we're going to create the function body. In here, all we have to do is to set the position of the player to the starting position. We can do that by using the global position built-in variable. This is going to set the position of the player scene. And this is a vector 2, so we can assign a vector 2 to this to change the position. So let's take a look at the game scene to pick a starting position. I'm going to select the player and then move it to the left side there. Then take a look at its position. Since the window is 720 pixels, placing it at 360 is going to place it in the middle in terms of its vertical position. And then it seems like 60 pixels is a good starting point for the horizontal position. So this is going to be our starting position, 60 by 360. Now we can go back into the player script, and in here we're going to say 60 by 360. Now we have a function that's going to reset the player. Now all we have to do is call this function when the signal is emitted in the enemy script. But how can we do that? How can we get access to the player here? Well, if you take a look at the arguments of this function, you will see that there is one called body. This represents the physics body that entered the area 2D. In this case, it is going to be the player. So we can use this to call the reset player function. We can say body, then use the dot operator, and then reset player. Just like that. Now we can play the game again. Go ahead and touch the enemy. And when we do that, we're going to get reset to the starting position, as you can see. Perfect. I want to go back to the player script, and I want to turn this into a variable instead of a hard-coded value that we enter in the function. To do that, we can cut this, and at the top, we can create a variable called spawn point. and we can set this to the vector 2, and then we can use this one here instead of that vector 2, just like that. When we play, it's going to be the same, but this is a better coding principle, or practice, you could say. This also makes more sense when you look at the code. You understand that this line is setting the position to the spawn point, but beforehand we didn't really know what this was at first glance. Alright, so that is going to be what we want to implement, but there's a small problem here. This signal of the enemy, the body entered signal, is going to be emitted when any physics body enters the area 2D. For example, if we place the enemy here, it is going to touch the wall, which is a static body, which is also a physics body. And when this happens, the game is going to crash because we're going to try to call reset player on the wall, and that function doesn't exist for the wall. So when we play the game, it's going to crash, as you can see. Invalid call, non-existent function reset player in static body 2D. So in order to prevent these problems, we only want to do this. We only want to call reset player if the enemy touches the player. To make this work, we're going to go into the player script, and at the top, right after the extends line, we're going to give this class a name using the class name keyword. And the name is going to be player with a capital P. We're going to save this, and we're going to go back into the enemy script, and in here we're going to write an if statement. If body is player, only then try to call reset player. This statement right here, this condition is going to be true if the body is a player scene, and it's going to be false if the body is not a player scene. If it is true, since this is an if statement, we're going to do this, and if it is false, we're going to ignore it. And that is going to fix our problem. So now if you play the game, the enemy touches the wall, nothing happens, but the enemy touches the player, it gets reset. Perfect, so that is exactly what we want to achieve. We are going a little bit fast explaining how these concepts work, like the is keyword here. This is all because, like I said, this is just an intro course. We need to go a little bit fast to get this game done, but in the complete Godot course, I go into detail explaining all of these concepts. So that is going to be what we want to do in this lecture. Now we have a function that is going to get called when the body entered signal is emitted from the area 2D of the enemy. And then once we make sure that the body is the player, we are resetting it. Let's leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to learn how to use inherited scenes and create multiple enemy types. Let's go ahead and get started. So at the moment, we only have the red enemy type in the game, which is going to go from top to bottom when we play the game. But what if we want to create more enemy types? Do we have to create the enemy scene multiple times? No. In Godot, we can use inherited scenes to make this process easier. What we can do is we can create a base type, which is going to be the enemy scene with the enemy script, the area 2D, and everything else that we created for it. And we can use this as the base type and create inherited scenes from it. In this case, we're going to create 3 different types of enemies: red enemy, yellow enemy, and green enemy. Because we create these as inherited scenes, they're going to inherit all of the functionality from the base type, from the enemy. They're all going to have the script, they're all going to have the area 2D with the signal, and everything else. But on top of that, we're going to be able to customize each one of them. For example, we're going to give them a different sprite. We're also going to give them a different movement animation. This way, we can create the base functionality just once in the base type and then share it among multiple scenes. So first of all, we need to get inside of the enemy scene, and we're going to delete the animation player. And that is because the animation player is going to be created in each of the inherited scenes, but we're going to keep everything else the same. For the sprite, we're also going to reset the texture, because again, this will be set for each one of the types. Once we do this, we can save this scene, and in the game scene, we're going to delete that enemy as well. Next up, we're going to go to the scene menu, new inherited scene, and then we're going to pick the enemy scene as the base, then click on open. That is going to create a new inherited scene from the enemy type. We're going to change the root node's name to be red enemy. and then we're going to save this into the scenes folder. As you can see, this inherited scene has all the nodes we created in the enemy scene, like the area 2D, sprite 2D, and the collision shape. And it also has the script along with the signal connection for the area 2D. Now all we have to do here is to give it a different sprite. So for the texture, we're going to use the red enemy. And then we're going to create an animation player in here. So we'll click on the root node, create an animation player, and we're going to basically recreate the move animation. So we'll create a new one, call it move. We're going to make this autoplay at the start of the game. We're going to make it loop back and forth. And then we're going to click on the area 2D, key the position at 0, 0 for the start of the animation, just like that. And for the end of the animation, we're going to place it at 600 on the Y and key that again. We're also going to set this to be cubic to achieve that smooth effect. That is basically the red enemy created again. We can save this and we can start using it. So we'll go back into the game, click on the enemies container and instance one of these red enemies, just like that. And it is going to work exactly the same, as you can see. But now we have this as an inherited scene with a base enemy type, which means we can start creating more enemies. We're going to create another inherited scene, pick the enemy scene again as the base. This time we're going to call this the yellow enemy. Save it into the scenes folder. For the sprite, we're going to use the yellow enemy image. Then we're going to create an animation player in here with the move animation. Make it autoplay, make it loop back and forth. And this time I'm going to animate it sideways. So we'll click on the area 2D. We're going to key the 0, 0 position again. But this time at the end of the animation, we're going to move it sideways. I'm going to move it 300 pixels to the right, which should be enough. And key this position for the end of the animation. And I'm also going to make it cubic, which is going to look like that. Great, so this is another enemy type we can start using. We'll save this, go into the game, click on the enemies container and instance one of these as well. Maybe we can place it here. Now we have two different types of enemies in the game. And if you touch the yellow enemy, it is going to reset us as well. Because like I told you, all the inherited scenes are sharing all the functionality from the base type. Next up, we're going to create the green enemy, which is going to move diagonally. So we're going to have to change the X and Y position in the animation at the same time. I'm going to give that to you as a challenge. Go ahead and create a new inherited scene for the green enemy. Then I want you to create an animation player and a move animation with a unique movement pattern. Make sure to also give it the green sprite as well. Then finally, instance one of these into the game scene. Pause the video, give it a go, and come back when you're done. Alright, let's go ahead and create a new inherited scene from the enemy base type again. We're going to call this the green enemy. Save it into the scenes folder. We'll give it the green image as well. For this one, you can see that the collision shape isn't really fitting. What we can do is we can click on the collision shape. We can make this a unique resource. If you change it like this, it's going to affect the other ones. You have to right click on it and make it unique. Or you can straight up use a different one. For example, a circle would be fine with this. But in this case, I'm simply going to resize the rectangle, which should be fine. Now we're going to create an animation player here with a move animation, which is going to be autoplay and loop. And for this one, we're going to make it go diagonally. We'll pick the area 2D. We're going to key 0, 0 for the start again. And then at the end, we're going to make it move both on the X and the Y. So maybe we'll make it move 200 pixels on the X and 200 pixels on the Y. And then we'll key this for the end of the animation. Make it cubic as well, and let's take a look. So that is going to be the movement pattern of the green enemy. Perfect. Now we can save this, go into the game scene, and we can instance one of these as well. I'll put it down here. And as you can see, this one is also going to work just fine. And now we have 3 different enemy types that we can use in order to create a level, which is what I'm going to do. First of all, I want to have 3 red enemies at the start. So I'm going to duplicate this 2 more times. Just like that. And then I'm going to place some yellow enemies right after them. Just like that. And then maybe we'll create 2 green enemies here. Like that. So that's going to be fine, but I think the problem is they're all moving at the same time. So let's make it so that some of them move in different directions. We can do that, for example, for the yellow one, by giving it a different scale in its transform. First of all, we're going to break this connection or this link. And then we're going to set the scale transform to be -1 on the X. And that's going to make it go in the opposite direction, as you can see. We can do the same thing for this green one as well. I'll select it and I'm going to set its X scale to be -1. And that's going to make it move in the opposite direction, as you can see. And finally, we'll make this middle red one go in the opposite direction as well, from bottom to top. To do that, we can set its Y scale this time to be -1, which is going to make it go from bottom to top. But you can see that the sprite also gets rotated. So we can right click on it, make it editable children, click on the area 2D, and we can rotate this by 180 degrees in order to fix that. Now we have this more interesting looking level where we can actually play and try to get to the end. Just like that. So that is how to create multiple enemy types using inherited scenes. We're going to leave it here for this lecture and continue in the next one. Hello and welcome. In this lecture, we're going to implement the win area. Let's go ahead and get started. Okay, so we're going to create the win condition for the game. We want the player to go from the left side of the level to the right side. And once it reaches the right side of the level, we're going to call that victory. In order to implement this, we're going to create an area 2D, just like we did for the enemy. This area 2D is going to detect the player. And once player reaches it, we're going to call the game over. This is going to be a new scene, so let's go ahead and create a scene. I'm going to close some of these scenes we have open, just to make some room here. This new scene is going to be an area 2D for the root node. We're going to rename that to be win area and save it into the scenes folder. The win area needs to have some graphics. I'm going to create a solid color for it, which is going to be green. That is going to represent the end of the game or the finish area of the game. To do this, we can learn how to use a new type of node, which is going to be a mesh instance 2D. This one right here. This is going to display a 2D mesh and a solid color. We're going to go to the mesh property here and create a new quad mesh. Then we're going to click on that and we're going to give it a size. For the height, I'm going to make it something like 750 or 760. Something that is a little bit larger than the window height. And then for the X, for the width, we're going to do something like 50 or 60. Something very thin like that. You can see that by default this is white. So we're going to scroll down to the visibility section here. And we're going to click on this modulate to give it a different color. That is going to open up this color picker. We're going to switch over to the HSV section. Increase the saturation to maximum. And then from the hue, we're going to pick a green color. And then we're going to decrease the alpha to make this transparent. Something like 60 is going to work fine. Now we can save this, go into the game and instance it to see what it looks like. We're going to place this at the right edge, just like that. And maybe move the green enemy to the side a little bit. So that is what it's going to look like. Now when we play the game, it is clear that we need to go to this side. You can also make this smaller if you want to. That is going to make the game a little bit more difficult. So it is up to you. For me, I'm going to use this entire vertical slice here. So next up, we'll go back into the win area, and we need to create a collision shape for the area 2D. Collision shape, 2D. For the shape, we can use a rectangle. I'm going to use a capsule just to show you what the capsule looks like. We don't need to make it perfect. In fact, we want to make it smaller than the mesh instance because we want the player to enter the mesh instance a little bit. Otherwise, if you make it perfect like this, the player is going to win the game right here, which isn't going to feel good. We want to make this a little bit smaller. In fact, even put it a little bit to the right so that the player enters the mesh instance and then the game is over. So that's going to be the difference there. We'll save this. And in order to actually create the win condition, we're going to use a script and we're going to use the body entered signal of the win area, the same signal we used for the enemy. But we're not going to do this in the win area scene. We're not going to create the script here. We're going to do that in the game. So we'll click on the game root node here. We'll create a new script. We're going to save this into the scripts folder. It's going to be called game.gd, that's fine. And we're going to connect the body entered signal of the win area instance to this script. I'm actually going to move the win area below or above the enemies, just like that. If you click on that, click on the instance and go to the signal section, you will see that it has the body entered signal here. We're going to connect it to the game script. And in there, inside of the callback function, we're going to detect when the player enters it. And I'm going to give that to you as a challenge. So go ahead and connect the signal, the body entered signal of the win area to the game script. And then I want you to print a message if the player enters the win area. Only if the player, nothing else. We did the same thing in the enemy. Pause the video, give it a go, and come back when you're done. Alright, inside of the game scene, we're going to click on the win area instance, go to the signals, and we're going to double click on body entered. We're going to connect it to the game. So let's click on connect. That is going to create the callback function here in the game script. And in here, we're going to write an if statement. We're going to say if body is player. Just like we did for the enemy, we're doing the same check. We're checking that the body that we interacted with is the player. If it is, we're going to print a message, so we'll just print win. In order to make this easier to test, I'm going to take the win area and place it next to the player, just like that. Then we can play the game. Take a look at the output tab, and as you can see, when we enter it, it says win. Now that we can detect the player, all we have to do is delete the player, which is going to be the end of the game. The player reaches the win area, it is deleted, and the game is over. We can do that by calling a function on the body, which is going to be the player in this case. We'll use the dot operator, and the function is called queue_free. This function is going to delete the player. Now when we play, enter the win area, the player is gone. Perfect. We're going to do it like this because we only have a single level, so we're simply going to delete the player. But for example, if we wanted to play this level again, we could call getTree, which is going to give us the scene tree, which is the object that is in charge of managing the scenes. And this has a function called reload current scene. We could call this in order to play the same level again. Or if we had multiple levels, we could call change scene to file. And then we could enter the file location of that scene. For example, if we had a game 2 scene, we could load it like this when the player enters the win area. But like I said, since this is a single level game, we're simply going to delete the player. And that is going to be it for this lecture. We're going to continue learning in the next one. Hello and welcome. In this lecture, we're going to create the background image and the win label. Let's go ahead and get started. Okay, so all the main gameplay elements are complete and we're basically wrapping up the game by creating the final visuals. We're going to start by creating the background graphics, which is going to be a sprite node inside of the game scene. So let's go ahead and create one. We're going to do a search for sprite 2D. We're going to rename this to be background. And then we're going to place this at the top of the scene hierarchy so that it is behind everything else. For the texture, we're going to use this blue bg.png, which is going to look like that. As you can see, at the moment, the pivot point is at the center of the sprite. We're going to go into the offset section here, and we're going to turn off this centered property, which is going to place the pivot at the top left, and this is going to make it easier to position the sprite. We can essentially just leave it at 0, 0. Next up, I'm going to go into the transform and scale this up by 2. You can see that this texture is very small, and there's a reason for that. This texture is meant to be tiled across the entire screen. But we can't just scale it up. We can't just do something like this. That is going to stretch it instead of tiling it. So I'll take that back. In order to do this, we're going to use the region section here. Currently it is turned off. We're going to turn it on. The sprite is going to disappear, and then we're going to enter the width and the height of the window here to tile it across the entire screen. The window size is 1280 by 720, but since we scaled the sprite up by 2, we're going to use half of the screen size, which is going to be 640 for the width and 360 for the height, just like that. That is going to cover the entire screen, but as you can see, the image is still not tiled. It is just stretched at the edges. That is because inside of the texture settings at the bottom here in the inspector, we need to set repeat to be enabled. And once you do that, it is going to be tiled across that entire width and height, as you can see. Now we can play the game, and we have the background image correctly displayed. Awesome. When you have a large sprite like this in the game area, you might accidentally click on it and move it, which is something we don't want. In order to prevent that, we're going to click on this lock icon while we have the sprite selected. And that's going to make sure that we can't click on it in the viewport. We can only click on it in the scene tab right here. So that's going to be the background sprite. Next up, we're going to create a text label that says you win, and we're going to make that visible when we enter the win area. This is going to be a new node we're going to add into the game scene. So we'll pick the root node, create a new node, and we're going to do a search for label. This one right here. You can see that this is green because it's a user interface node. We're going to create this, and we're going to rename it to be you win label. When you create it, you're going to get this orange box. You can move this and you can scale this up, change the size by these orange circles. In the inspector, you can enter a text. For example, let's say you win, and that text is going to be displayed inside of this box. By default, the text is going to be very small, so we're going to have to adjust some settings. First of all, I'm going to make the horizontal alignment centered and vertical alignment centered as well. And then I'm going to create some label settings, which is this option right here. We need to click on the empty section, new label settings, and then we need to click on that resource to open it up. In here, there's a section called font, and from this we can increase the size. We're going to increase it to be something like 120. We can also change the color, or we can give it an outline, which I'm going to do. The color of the outline is going to be black, so we'll click on the color picker here and turn down the value to 0 to make it black. And then we're going to set the size of the outline to something like 10 or maybe even 12. We have a ton of other settings here in order to customize this, but I'm going to keep it short and go with this. Let's place it in the center, just like that. Now when we play the game, we're going to have this you win label at the center. But obviously we don't want to see this until we enter the win area. So because of that, we're going to turn the visibility off by clicking on this eye icon next to the node. That's going to make it invisible. And then we're going to make it visible inside of our game script. This is going to happen inside of the if statement that we free the player, because this is the time that we know that the player enters the win area. In order to access the label from the script, we need to use the $, and then the name of the node, which is you win label. And then we can use the dot operator to access the visible property, which is a boolean that controls the visibility of this node. In this case, we're going to assign true to this to make it visible again when the player enters the win area. Now when we play, it is invisible, but when we enter the win area, it's going to become visible, as you can see. Great, so that is how it's going to work. Now we can basically put the win area to its proper location, which is going to be end of the screen like that. And we can essentially play the game, because at the moment we have a complete game. Everything about the game is ready. Oops. If I can actually win, let's see. Just like that. Great, so that is going to be the background image and the win label of our game. Hello and welcome. In this lecture, we're going to play the background music and the player hit sound effect. Let's go ahead and get started. Okay, so we're going to play two different sounds in this game. First of all, we're going to have a background music that's going to start playing at the start of the game. And then we're going to create a sound effect for the player when it touches an enemy. First of all, we need to download the assets. You're going to find a link to this at the bottom of this lecture at the resources section. The file is called danger-audio.zip. You're going to right click on this after you download it and extract all. And in here, you're going to find two files, the background music and the hit sound effect. You can select both of these and drag them into the assets folder. They're going to be imported into our project. And now that we have two different types of assets, we can create folders for these inside of the assets folder. I'll create a folder called textures and then also a folder called audio. We're going to select the audio files. I'll hold down the control key and select both of them and then move them into the audio folder. And then I'll select the rest of these files and move them into the textures. Just like that. First of all, we're going to implement the background music. That's going to happen in the game scene. Here we're going to create a new node and the type is going to be an audio stream player. You can see that we have three different versions of this. The basic version, the 2D version, and the 3D version. The basic version is simply going to play a sound without any position. 2D version is going to play it in 2D space, and 3D is going to play it in 3D space. For example, for the 2D version, let's say that we play the sound effect here in the game, and the player is over here. The player might not hear the sound effect or might hear it at a low volume because it is far away, but if we play it here right next to the player, then the player is going to hear it in full force. But if we play it using the audio stream player, it's not going to have any position. It's always going to be at the same volume. So that is the difference there. For the game that we're building, the position doesn't really matter. It's a very small game world in the first place, so we're simply going to use the basic version. We're going to rename this to be BG Music. Place it at the top. This has a stream property right here. This needs to be the file that you want to play. In this case, we're going to drag the bgmusic.ogg into this. After you do that, you can click on this playing property here to hear what it sounds like. Then we're going to turn on this autoplay property here, and that's going to make it so that when we start the game, this sound effect or this sound node automatically starts playing. Just like that. Next up, we're going to go into this parameters section and turn on looping. Because we don't want the sound, the background music to stop playing, we want it to loop over and over again. You might also have to double click on the file here in the file system and enable looping here and then re-import in case the looping doesn't work for you. So that is going to be the background music. Now we're going to go into the player and create the hit sound. And I'm going to give that to you as a challenge. Go ahead and create an audio stream player node inside of the player scene and then assign the hit sound effect file to the stream property. Pause the video, give it a go, and come back when you're done. Alright, we're going to create a new node, which is going to be an audio stream player. We're going to rename this to hit sound. I'll place this at the top. And then we're going to give it the hit.wave file as its stream. We can click on playing to hear what it sounds like. We're not going to turn on autoplay for this because we only want to play the sound when the player hits an enemy, which means we need to play this inside of our script. We know that we have a function here called resetPlayer, and we know that this is called when the enemy or the player touches the enemy. So that is the perfect place to play the sound effect. After we set the position, we're going to get a reference to the sound node by using the $, hit sound, And then we're going to use the dot operator to make a call to the play function, which is going to play the sound effect. With this, we can save and play. And when we touch an enemy, the hit sound is going to be played, as you can see or hear. And with that, we are essentially going to finish our game. Congratulations for making it to the end of the course. We covered a lot of information really quick, but we have just scratched the surface of what is possible with Godot. Now that you have a basic understanding, I would recommend you to get inside the Godot Academy and start the complete Godot course. In that course, you're going to create multiple amazing games while doing a deep dive into all of the essential topics that you need to know to become an advanced game developer. I'm going to be by your side, answering all of your questions, giving you customized feedback, and helping you at every step of the way. I'm looking forward to having you in the Academy, and I can't wait to see the games you're going to create. So click the link below and get started in the Godot Academy today.